Good day, students. This is Ndefo Okigbo classes, lecture 2. My name is Ndefo Okigbo. I am a teacher of science, engineering, and mathematics. We have started this lecture series. We started with engineering. We have done lecture 1. In lecture 1, we thought about forces in a straight line. But this time, we are talking of forces that meet at an inclination, not in a straight line. Forces that are in a straight line want to get their resultant of inclined forces. At the inclination, we can get their resultant. To get the resultant of these forces that are meet at the inclination. Example of such forces is, let's take for instance, that two children are to throw balls onto a particular point on a wall from different inclination. When the two balls hit the wall simultaneously, the wall responds in a reaction. To find that reaction, that's the resultant of the effect. It's such type of action that we are trying to get the resultant. There are a lot of such things in life when two things meet at inclination and impact on a third situation at the inclination. We have to get the resultant. That's what we're trying to get. Forces, even when in a stream, when somebody wants to swim across, as the current force of the stream current force is moving in a given direction, and the swimmer comes at an inclination. Now there is a resultant of the two actions, that of the stream and that of the swimmer. That's also the kind of thing we want to calculate. Now, to do this, there are different ways whereby we can get the resultant. One, we have a method we call the triangular method of triangle. Two, we have method of parallelogram, depending on the angle at which they met. We also have method of rectangle if they met at an angle of 90 degrees, because the angle that is between two sides of a rectangle is 90 degrees. So now let us start and talk of how to calculate such the resultant of such forces when they meet at an inclination. Let's take for instance this. Look at this force F1, and there's another force coming this way, force F2, and they met at, let's say they met at 90 degrees. Let's start from there. They met at the 90 degrees here. Now we're to get the resultant by method of triangular method. What we do is to bring down and sketch the forces. Let's sketch force 1, F1, this way. We now bring force 2 from where the F1 stopped. Force 2 takes off from where the F1 stopped, maintaining its orientation. That is, it will be parallel to the original force 2. That will make the angle between them 90 degrees. And if the angle between them is 90 degrees, we now move from force 2 back to force 1 to make a closure. That closure, that force that brings about the closure is the resultant by triangular method. Now, if that's the case, it is simple. To calculate the resultant becomes a very simple thing using Pythagoras theorem, because the angle here is 90 degrees. If it is not 90 degrees, we use the cosine rule. As a matter of fact, the cosine rule is an extension of the Pythagoras theorem. I will explain. Now, to solve this one, which where two of them met at 90 degrees, the reaction, square of the reaction is equal to F1 squared plus F2 squared. So, because that is Pythagoras, using Pythagoras theorem. Now, take for instance that F1 is equal to 3 newtons and F2 is equal to 4 newtons. Then R squared becomes 3 squared plus 4 squared. That means R is equal to square root of 9 plus 16, which is equal to square root of 25, which is equal to 5 newtons by method of triangle. If the angle between them is not a right angle, for instance, the angle between them is 60 degrees, for instance. That's the angle between the both of them, R1 and R2. R1, look at R2 coming this way. That's F1 and F2. F2 coming this way, and this angle is 60 degrees. So if we want to project, we have F1 at the end of F1 we have F2 maintaining its orientation, it will be parallel to the original F2. You will see that in such a situation, the angle between them now will be 180 minus 60, which is 120. Then we now from F2 close up to F1 with R. R is a resultant. Now, to calculate the resultant R, we use the cosine rule. We use the cosine rule, which in this case is equal to R squared is equal to F1 squared plus F2 squared minus 2 F1 F2 cos the angle between them, in this case 120 degrees. So in this case, if for instance F1 is, let's say 6 Newton, F2 is 2, let's say 2 newtons, F2, then R2 will be 6 squared plus 2 squared minus 2 times 6 times 2 cos 120 degrees, which is equal to 6 squared 36 plus 4, that is 40, minus 2 times 6, 12, times 2, 24, cos 120. This is equal to cos 120 is minus half. So it's equal to 40 minus, that's minus half, minus times, that's become plus, and half of 24 is 12, which means it is equal to 52. R is equal to square root of 52. The resultant is the square root of 52. You see that the Pythagoras theorem, the cosine rule is an extension of the Pythagoras theorem. While we had F1 and F2 without including the angle, is that the angle between them is 90 degrees. And the cos 90 is 0. So if cos 90 is 0, by the time cos 90, which is 0, multiply these two, it becomes 0, left only F1 and F2. So by the method of triangle, when two forces are at an inclination, what we do is to draw the two forces. Draw the first one at the tip of the first one. That's where the first one stopped. Second one starts as it is done here. F1, where it stopped, F2 comes up. From F2, the resultant closes it up. That closure shows that it is now in equilibrium, because it's the resultant that will bring it to equilibrium. So when we do this, we now get a triangle, and the angle between them this time will be 180 minus that angle, previous angle at which they are meeting, when it's arranged well for calculation. From there now, R by cosine rule, R squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos whatever angle, which in this case is 120 degrees. So we get the resultant. This is the method of triangular method of calculating forces that meet at an inclination. The forces are not in a straight line, not on the same line, not even parallel, but they meet at inclination. Now, since we have done this, we also want to solve the same set of forces, getting their resultant using the method of rectangle or method of parallelogram, depending. So if we're to do that, we have the first one, that is when F1 was 3 and F2 was 4. Let's see where the angle between them was 90 degrees. So if it was when the F1, F2, F1 equal to 3, F2 equal to 4, and the angle is 90 degrees. Now, by rectangular method, look at the two forces, F1, because the angle between them is 90 degrees, so we use a rectangular method. This is F2, F1, which is 3 newtons. This is F2, which is 4 newtons. The angle is 90. In this case, what we do is the resultant will be between the two. It will be the hypotenuse. So if we close this rectangle, we have this as 90, this as, we close the rectangle, we have this as 90, So here, this is the resultant between the hypotenuse of the rectangle formed. So if that's the case, you will see that the angle here is 90. And this is R, the same way. It comes back to, because this is now ABC, triangle ABC. So with that triangle, we come back to using the Pythagoras theorem as it is already shown here, we get also it is equal to 5. Now, if in the second one where the angle was 60 and the forces, the angle between them was 60 and the forces were F1 6 Newton, F2 2 Newtons. If we are to solve this by method of this time method of parallelogram, because the angle between them is not 90, so we use the method of parallelogram. We now sketch the two forces. F1, the angle between them is 60. This F1 is equal to 6 Newtons. This angle is 60 degrees. This F2, which is equal to 2 Newtons. So if we close this to form the parallelogram, if we form the parallelogram, that means this is now, we can extend this F2, so that this becomes F2. The angle between them here, if you subtract 60 from 180, you get 120 degrees. So we now look at this resultant. The hypotenuse is the resultant, R, and it will give you the same thing, R squared, this triangle A, B, C, by cosine rule. R squared is equal to F squared plus F1 squared plus F2 squared minus 2F1 F2 cos the angle between them, which is 120. So it is equal to 6 Newton plus 6 squared, plus 2 squared minus 2 times 6 times 2 cos 120 degrees. This is equal to 6 squared is 36 plus 4, that is 40, minus 24 cos 120, which is equal to 24 times 120. Cos 120 is minus 0.5, half, plus minus 0.5 times plus 24, that will give you plus 12. 40 plus 12, which is R is equal to square root of 52. So that is it. How to get the resultant of forces that are at inclination, either by method of triangle, method of rectangle, method of parallelogram. Thank you very much. At the end of the class today.